Good afternoon, students, future scientists, critical thinkers. Today, you're going to learn something that's going to change your life. I want you to get ready. Let's kick things on by diving into the topic. What topic do we have today? The topic is Introduction to Projectile Motion. And this topic is specifically meant for IBDP students and CSEC 4 students. And as usual, my name is Mr. Chiadi. I'm your physics teacher. All right, so let's go to the objectives of the lesson. So at the end of today's lesson, you will be able to define projectile motion, distinguish between horizontal and vertical components of the motion, and also you'll be able to predict and describe the parts of a projectile motion using simulation and some reasoning. All right, so let's dive into the lesson. But before we go deeper into the lesson, I'd like you to watch this video clip of a soccer goal. Please pay attention to the path the ball takes. It's not just magic. We're going to see physics in action. Okay, now I want to hear from you now. Type in the chat what you think is happening on that ball once he leaves the player's foot and flies through the air. Don't overthink. Just tell me what comes to your mind. Okay. I've seen some responses. Somebody said gravity. All right. Gravity. Okay. Somebody said air resistance. Okay, good. Air resistance. Air resistance. Okay. So, C, kick force. Kick force. All right. And I see weight. Weight. Okay. All right. Interesting. So your answers are brilliant. It shows you are thinking like physicists already. But here's the key idea. After the ball leaves the foot, it's no longer being pushed. So the dominant force acting on it is now gravity, because gravity is pulling it down. That's why you saw the curving part of the ball as it was moving through the air. And this is what we call the projectile motion. We call this kind of motion projectile motion. And then understanding projectile motion will help us to unlock and understand how we throw, launch, and shoot, and even travel through space. And that's so exciting about this. So let's dive into the science behind the curve. All right, let's go into context. Now, projectile motion is not just in soccer or in basketball, it's everywhere. And I want you to do something now. I want you to tell me, where else do you see an object follow a curved path. I want you to think of everyday life, sports, nature, even amusement. And where do you see something follow a curved path? Now, get to your chat and start sending me responses. Okay. Oh, nice. Someone say fireworks. Yes. Yeah. Correct. When you release fireworks in the air, they usually follow a curved path. Yeah, fireworks. Okay. Would somebody say fountain? Oh, nice. Fountains. Yes, fountains follow curved path. Okay. Yes, long jump. Okay, good. Long jumps. Yes, long jumps. Uh, roller coaster. Yes, roller coaster too. Yes, roller coaster. That's nice. Oh, roller coasters. Okay. Roller coasters. Okay. That's nice. So now you see the connections. Okay, you are all right in the suggestions you gave. They are all projectile motion. You see, the beautiful thing about this is that they are all governed by the rules of physics. The same rules applies to all of them. So, and that's why as we understand this motion, it helps us to make the visible rules of the universe very visible to us. All right. So now let's go to a more detailed definition of projectile motion. All right. So let's go there to the slide. Okay. Now, as you can see, it says, now a projectile motion from your side, from the slide, this is a more detailed definition of it. But actually, a projectile is an object that is thrown or launched into the air and moves only under the force of gravity. Okay, so it moves only under the force of gravity. So the initial push sets it into motion, but after that, gravity takes over and gravity creates the curved path. All right, so that's the definition of projectile motion. You can also say a projectile is an object thrown into the air with only gravity acting on it after the launch. So that's it. Okay. But there's something else about projectile motion I want us to see. You see, there are two types of motion associated with projectile motion. You have the horizontal aspect of it, that's the horizontal component. And when we talk about the horizontal component, we're talking about the constant velocity of the projectile. So when the horizontal component, when the object, the projectile is moving horizontally, the speed or the velocity is constant. That means there is no acceleration in the horizontal direction. Okay, and we also ignore air resistance. That the idea is that so that we can make our calculation simple. So movement in the horizontal direction is with constant velocity or constant speed. So there's no acceleration in the horizontal motion of a projectile motion. Then the second independent motion of a projectile motion is the vertical motion. And this is where the action is. The vertical aspect of the projectile motion, here gravity pulls the object downwards and causing it to accelerate at 9.8 meters per second squared. We can say 9.8, that's 9.8 meters per second per second. All right. So let's look at this more clearly. Let's visualize, let's see this more clearly. Suppose I have the ball roll off on a cliff. This is my cliff. Cliff. Okay. The cliff. My drawing is not very good anyway, but this is a cliff, and then this is a ball. Ball. Okay. So let's say the ball roll off a cliff. So horizontally, it's going at the same speed. Horizontally, keeps going at the same speed, but gravity pulls it faster and faster. All right. So gravity is pulling it fast. It's gravity acting in this direction. Okay. So gravity pulls it down faster. All right. So gravity faster. All right. So now the mixture of the sideways and the downward motion is what creates the curve. Okay. So at times this is called a parabolic path. Also called a parabolic path. Parabolic path. Okay. Parabolic. So the horizontal motion plus the vertical motion is what creates the curve. So it's beginning to make sense now. It's what creates the curve. Okay. Someone has a question. That's good. Let me see. Students. Okay, two students have questions. Okay, let's see the question. So, okay, it says, why doesn't gravity affect horizontal motion? Good. Let's see the second question. It says, what if there's no air? All right, a fantastic question. Now, I want you to think of, let's start with the first question. I want to think of gravity like a vertical magnet. And it only pulls straight down. It doesn't care how far something is moving sideways. It's only interested in pulling things down. That's why the vertical component of projectile motion is completely independent of the horizontal motion. So gravity just pulls it down, doesn't care about how it's moving sideways or not. Okay? And for the second question, it says, what if there's no air? Well, yes, we usually ignore air resistance. And the reason we do that is to make our calculation to be simple. Okay, make it easy for us. Okay, so the speed at the horizontal level stays the same. We ignore air resistance, especially for the IB and CS level. Usually ignore air resistance. But in real life, air resistance has an effect on projectile motion. But at this level, we usually ignore it. Okay, all right. Now let's make progress. Now we're going to give more life to projectile motion. And what we're going to do now is that we're going to bring the theory, all that I've discussed so far, to life. And we're going to use a PhET, projectile motion stimulator now. So we move from guessing to experimenting. Now let's go and I'll start by sharing my screen. We'll share my screen. Okay. So this is the PhET stimulator. All right, so what we're going to do here is that we're going to follow step by step. First, we'll try, this is a cannon. Okay, a cannon. So I'm going to set it first to 30 degrees. I'm going to use, I will use a cannonball in it. And this one I'm going to use to measure the range. All right. So what do we do now? Now, before I launch it or before I fire it, I want you to predict what will happen if I increase the angle to 45 degrees. Will it go further or shorter? Just use the chart. Okay, so I'm going to fire it now and then start sending me your predictions. Now, let's do this. Wow. Okay, nice. Now let's check the range. Let's check the range. The range is 22.8 meters. That's the range. 22.8 meters. All right. So let me check the chart. Okay. Somebody said further away. Okay, if I increase the angle to 45 degrees, somebody says it's going to be further away. Okay. Someone say it's going to be higher. Person says it's higher. Somebody says shorter. And then another person say it depends on speed. Okay. All right. So those are interesting predictions. So let's test it. Okay. So let's test your predictions. Now, let me move the cannon to 45 degrees. Let's move it to 45 degrees. And then I will fire. Wow. So let's see. Let's see. Good, good, good. Wow. So it went further away. This is 24.79 meters. And then let's check the height. Okay. As you can see, the height has increased. Okay, this is the height. Let's see the height. The height is 7.7 meters. Let's check the height for 30 degrees zone, the highest point. This should be the highest point. Well, should be the highest point. Okay, this is 4.86 meters. So you can see, increase the angle, it goes further away, and the height increases. Okay, so your predictions, some of your predictions were correct. Now let's crank up the speed. So suppose we increase the speed. What do you expect to happen? I want everybody to send me your response. Send your response to me. Okay, suppose I increase the speed. You know, the speed, as you can see here, the speed of the cannonball is 15 meters per second. So let me increase the speed to, let me double it to 30 meters per second. So let's see what's going to happen. All right. So send in your predictions on chat. Okay, so let's fire them. Wow. It's come far away. Wow, that's nice. See? So he has gone far away. He has gone even out of range. Has gone so far that we cannot even measure the range. So that means increasing the speed increases the range, the height, and even the time. So you can see from the simulation that we can actually also measure the time. So, and apart from the range and the height. So this is what physics is all about. This is the heart of physics. You predict, test, and then you learn. So that's what physics is about. So now let's get back to our slide. And we're going to do a quick quiz, okay, to check our understanding of what we have done so far. So let's get back to slide. Okay, let's go to the questions. Quick quiz. Okay. Now, everybody send in your answers on the chat. First question says, what causes the projectile to accelerate vertically? You just type in the letter Then the second question says, which motion remains constant during the projectile motion, ignoring air resistance? Okay, let's see the answers. Oh, brilliant. Okay, first one is gravity. That's correct. Gravity, that's A. Good. Second one, okay, everybody says B, horizontal. Okay, okay, good. Now, let me ask you this question. Okay, ready? Now, if you launch the projectile straight up at 90 degrees, what is its horizontal range? So let's say you try to launch it from the simulation and it's at 90 degrees. What is its range? That's the horizontal range. I'm waiting. Oh, good. Zero. Yes, zero. Good. Zero. That's so smart. All right. So finally, gravity causes vertical acceleration, and then horizontally just keep gliding forward. But when you go straight up, there's no horizontal component. So when you fire the cannon at 90 degree, there's no horizontal component, there's no range. Okay? So this concept formed the basis of everything from free throws to moon landing. So all the things we learn here are the fundamental that form the basis for all the things that we do with regard even up to moon landing. Now, before we conclude this lesson, here's a question I wouldn't answer yet. I'm going to give you a question, but I wouldn't answer it now. I want you to think about it. This is your exit challenge. This will be your exit challenge. Okay? And here is a question. If you fire a cannonball horizontally, you can see it on the screen now, from a cliff, and at the same time drop another ball straight down from the same height, which one hits the ground first? All right. Okay. Ahmed said same time. Well, I wouldn't answer the question now, but I want you to think about it, and we will go through it in the next lesson. We'll experiment it in the next lesson. Okay? So keep your answers, think more of the answer. In the next lesson, we're gonna go through it. And we're gonna use the PhET and find out if our answers are correct. All right, so as we wrap up, I want you to drop one word, just one word that describes something new or exciting you learned today. Just one word. Oh, nice. Somebody say curved path. Somebody say angle, gravity, motion. Awesome. Interesting. Nice. Nice. Thanks so much. You've really done amazing today. You have so much energy. You ask great questions, make predictions, tested your ideas, and thought critically. That's exactly what we do as scientists. I want you to keep the energy going, and I promise the next few lessons, you'll see the world differently. Like I told you at the beginning of the lesson, this lesson is going to change your life. You're not just learning physics, you are learning how to think like problem solvers and innovators. Thanks so much for your focus and curiosity. Until the next lesson, keep asking why, keep testing your ideas, and always stay focused. Bye for now.